All right, today we're going to learn how to solve systems by combination. Now, I want you to put another word under combination, because this is really what's going to happen, is this idea of elimination. We are going to combine the system of equations, and it's going to eliminate a variable. So let's see how this works. You're going to be asked to solve the system. So let's say that we have 4x plus 6y equals 32, and 3x minus 6y equals 3. Okay, and this is my system of equations, two equations. Well, if you see the title, we said combination or elimination. You're going to enjoy these problems because they're pretty easy. All we really need to do is add the system. And if you look at the system, it's going to become obvious why I add the system. Okay? If I add this system, 4x plus 3x makes 7x. But what happens here? Don't they go away? Isn't 6y, positive 6y, and negative 6y 0? So in other words, they just go away. And the y variable has been eliminated. And now I just have equals 35. So I have this very simple equation, 7x equals 35. I divide both sides by 7, and I get one part of my solution, the x value. But remember, that's not the entire solution. I need a y value. So what we're going to do is we need to plug this 5 back in to one of the original equations. It doesn't matter which one. I'll just use the top one. 4x plus 6y equals 32. I'm plugging this 5 in to x. So now I have 4 times 5 plus 6y equals 32. And it's a simple equation to solve. 20 plus 6y equals 32. I'll continue that on the next screen. 20 plus 6y equals 32. I would subtract 20 from both sides. 6y equals 12. Divide both sides by 6. The y value of the solution is 2. Remember, you have not solved the system until you have an x and a y value. Our x value is 5. So the solution to this system is x equals 5 and y equals 2, or we could write it as an ordered pair because that's what it is anyway. It's a point of intersection. Remember that when I solve a system of equations, we're looking for this point where the lines intersect. Okay? And so in this case, that point is where they intersect. Okay? Let's do another one. Two n plus 5r equals 6. And 9r plus 2n equals 22. Now, let's pay attention here. If I add these two the way they are, do you see that they are not lined up? Look, I've got an n below an r, right? So let's rewrite this thing so they're lined up. Let's do that first. I'll leave the top one alone. 2n plus 5r equals 6. But the bottom one, I need the 2n here. So that'll be plus 9r equals 22. I just used the commutative property to rewrite the bottom equation. Now, another thing we need to pay attention about is if I add these two, is anything going to disappear? Remember on the last problem, which I've scribbled on now, I had a positive and a negative 6y. I don't have that here. So what we're going to do is we're going to multiply one of these equations by -1. If I multiply this equation right here, if I multiply the entire thing by -1, which is a legal algebra step, by the way, then I will have the situation that I want. So the top one stays the same, 2n plus 5r equals 6. And if I multiply every term on the bottom equation by -1, then I have -2n minus 9r equals -22. All I did was multiply the entire equation by -1. Does everybody see that? And guess what? Now the process is exactly like the last problem. Now I can add these two, and a variable will go away. 2n and -2n make 0. They go away. 5r and -9r make -4r equals -16. And now we have eliminated a variable. So divide both sides by -4. So r equals 4. But I'm not done with the problem until I know both variables. So now I need to find out what n is, and it does not matter which original equation I use. I'll use the top one. 2n plus 5r equals 6. I'm going to plug that r in to that original equation so I can find out what n is. 2n plus 5 times 4 equals 6. So I have 2n plus 20 equals 6. Subtract 20 from both sides. 2n equals -14. I think it's obvious that n will be -7. And now we have solved the system. Okay? One last problem, then we're done. This one is given to us in words, but that does not make it any harder. The sum of two numbers is 15. So automatically we're thinking of two variables. I would think x and y. The sum of two numbers is 15, and then they give us this other statement. 3 times the first number minus the second number is 28. You're going to find this problem is exactly like the ones that we have done so far. First, the sum of two numbers is 15. How about x plus y equals 15? What we're trying to do here is set up our own system. So we need to come up with two equations. There's the first one. Does that equation make sense? Isn't sum the answer to addition? Now, 3 times the first number. How could I write that? Isn't this the first number? Right? So 3x. Minus the second number. Minus y. Is 28. There's my system of equations. Do you see that I already have opposites here and here? I've got a plus y and a minus y. See that? Right? So I can go ahead and add these two. Okay, just like we've been doing. I'm ready to add. What's positive y and negative y? 0. They go away. What's x plus 3x? 4x. So 4x equals 43. This one comes out to be an ugly answer, right? If I divide both sides by 4, I get that x equals 10 3/4 or 43/4. And just like before, you would have to plug that x into one of the original equations, like x plus y equals 15. You'd have to plug that in for x to finish solving for y. Okay? So if we use 43/4, I'll go ahead and finish this, even though it's got fractions. 43/4 plus y equals 15. I'm going to subtract 43/4 from both sides. Let me go to a new screen. 43/4 plus y equals 15. If I subtract 43/4 from both sides, I've got to deal with the fraction. So I am subtracting 43/4 from 15 over 1, and the common denominator is 4. So I need to multiply top and bottom by 4. So now I have 60/4 minus 43/4, which is 17/4. And that is the y value of our solution to the system. We already found the x value. And we will look at one other situation, not an entire problem. I want to just ask you to pay attention to which method I use in these two situations. We're not going to solve these two. I just want you to see the difference between these two systems. So there's the first system. Here's the next system. So there's my two systems. Which one of those two is ready to add? A or B? B is ready to add. Good. This one is ready to add the system because I have a positive 7x and a negative 7x. A is not ready, is it?
No.
So you need to multiply one of those by -1 first. Okay? This one is not ready, so you need to multiply one equation by -1 first, which we have already completed an example like that. And we're going to stop there for today.